So we're going to start with the bless you. And so we're going to talking more about separable differential equations today, and specifically recognizing and solving differential equations that result with separation of variables. So we've talked about this briefly. All our separation of variables has been fairly straightforward, and it's really the most important part of solving a differential equation is to separate them. So we're going to keep going on that idea. We're going to solve. We're going to use different differential equations to model applied problems. We're going to play with self-fields, and we're going to find particular solutions. So here is an application. We've got the rate of change of the number of coyotes in a population is directly proportional to 160 minus the number of coyotes, where t is the time in years, where t of 0 equals the population. When t equals 0, the population is 300. When t equals 2, the population is increased to 500 by the population when t is 3. So the first thing we're going to do is identify the rate of change, which is the dn dt, the n being the population of coyotes, and t being time. And so now that we have that, we're going to use k for our constant proportionality. Step 3 is to set up an equation. So directly proportional, directly means we're going to be multiplying here. Inversely proportional means you'll take k and divide it by whatever the expression is. So there we are. Then we're going to, it's Newton's law of cooling. It reminds us of that. We're separate our variables and integrate. And you might want to slow me down. I'm going a little fast. Integrate, and so we've got the negative absolute value of 650 minus n plus kt plus equals kt plus c1. Raise both sides to this, make both sides the power of e. This comes out, and absolute value goes away. And then we've played games with rewriting this several times. So now we have that, and then we're going to use our initial conditions to solve for our variables. So we've got that initial condition, and so c is 350. And then our second initial condition, so k is this number. And again, 3 decimal places at all times. I like to, once I hit my calculator right here, leave this number in my calculator so that it stays, it's always answer, 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 just to make my final 3 decimal places as accurate as possible. And so now that I have my equation, I'm going to go ahead and plug in 3, and there's my answer. There's about 552 coyotes in 3 years. And the howling's a little annoying. So we've talked about this before. This is a very straightforward. We did a problem like this on Friday. I helped several of you with problems like this on WebAssign. It's pretty straightforward. The difference is pulling it out of the words. So the rate of change with respect to y with respect to x is proportional to the product of y, and the difference between y and 4 is a slightly different kind of problem. We're going to go ahead and write, and so there is our equation. So the product of y and the difference between y and 4. And so there's my equation. And I'm going to go ahead and figure out which slope field it has to be. And so we're multiplying to, it's basically an x squared, but it's y. And so it's a little confusing. So slope is y squared minus 4y think it would go sideways, but I don't see anything doing what I think it should do. I think it should be like A, but sideways. Never quite know what to do. So we're going to go and plug in some numbers. So when y is 1, we've got a positive times a negative. So at 1, I should have a negative slope. I'm not sure. We'll cut back and think about that some more. And a particular solution that satisfies the differential equation. So we're going to go and separate our variables first. We have that. So separation of variables. We're going to integrate both sides. This integral is a little harder to do. We're going to have to use u sub for that integral. Except for we can't use u sub because we already used u, so we're going to use w substitution. And so we have this. And then we can go ahead and plug everything in. And there is our answer to this point. So we're going to make both sides the exponent of e to move our, oh, actually I guess we're going to try c right here. U of 0 is 1. So we're plugging in 1 and for y, for u, and 0 for that to give us the value of c. C is 1/2. And then we're going to make both sides the exponent of e. And so that is our final answer right there. Okay, so we're going to leave it here for today. Don't know that this was the most helpful video I've ever made. I'm a little tired. We'll go ahead and see. Let's actually move ahead. So find an equation of the graph that passes through the point and has the given slope. Let's go ahead and do this problem from scratch and see what we can do. So we're going to rewrite this as dy dx first equals negative 2y 3x. If we cross multiply, we get 3x dy equals negative 2y dx, which is not helpful because x and y are on the wrong sides. So we're going to go and divide. We've got dy divided by negative 2y equals dx divided by 3x. So we're going to go ahead and integrate from here. And so we have the natural log actually, let's go ahead and put this negative 1/2 in front. So we've got negative 1/2, the natural log of y, absolute value, equals 1/3 the natural log of x plus c. Should not be there. And bringing these back up as exponents. Excuse me. Is right there. So we've got y to the negative 1/2 using e as our ln x 1/3 times e to the c. And so y to the negative 1/2 equals x to the 1/3 times c. And so then we're going to use our initial condition. So when y is 1/2, 2 to the negative 1/2 equals, so let's see what happens, 8 to the 1/3 times c. So we've got 1 over the square root of 2 equals 2 times c. So 2 or square root of 2 over 2 equals 2 times c. And so c equals the square root of 2 over 4. And so I believe, if I've done this correctly, and like I said, I'm not particularly untired, y negative 1/2 equals x to the 1/3 times the square root of 2 over 4. And so to get rid of this, square both sides. I think. I don't really know. This is what I think. We'll talk about that more tomorrow. Hopefully I have some sort of idea what I'm doing. And like I said, not sure. We'll see. We'll talk to you soon. Good luck today.